Hi, in this video we are going to go over the solution of the problem valid palindrome. Palindrome is defined as a word, phrase, or a sequence that reads the same backwards and forwards. For example, the word madam. So you see that is from here or here is both madam. Or nurses run. So we can say from the backward it said nurses run. So interesting. Considering only alphanumeric characters, so if it is a special character or space, we ignore it. For example, if I have an input like this, a man, a plant, a canal, and Panama, so if I have this, that is actually true. Here, race a car is not. Let's start solving problems. So I'm going to have two pointers. From the left side, I call it right, and I have the pointer right, that pointer left that starts from the right side. So I give the first value to the pointer right as 0 as the index, and to the pointer left that is coming from the right side, I call it, I give the value len sub s minus 1. Okay, so again, pointer right is going to start here and going to right. It starts at the left and go to right, and pointer left starts on the right side and goes to the left. Okay, and we have those things, and I say while right is less than left, what we do, we say right plus equals 1. I go one step forward, and I also go one step backward for the left. So I go one step forward for right to go 1 1 1 and left backward until I have them equal. That is end of the while. And while I'm doing that, I say if s right is not equal s left. So if s right is not s left, return false. Otherwise, at the end of while loop, I return true. Okay, I need to remove the pass, and that should work. Okay, let's run it. Okay, you see that is true for the word madam. Perfect. Now let's the situation that I have some space or a special character. For example, for this example that I have a man. So when I reach here, so for example here, that is empty space. So right now code doesn't handle that. So I have to handle that situation. I can say while not s right is a alphabetical numerical. Okay, then I say 1. So I'm just saying if that things that you saw on the right when you are moving forward, that is not alphanumerical, that is not alphabet, that is not a number. If that's the case, go one more. Go one more. But if I do that, I need one thing. Because now I moved right one more to the right. So I should make sure still right is less than left in my main comparison, which is here. So I have to come and say add one more condition here. Again, I say here s of right, if it is not alphanumerical, if it is not a number, if it is not a alphabetical alphabet, in that case I move right one more to the right. But I have to check again in my main condition that right is less than left, because there might be a situation that right becomes equal to left. Okay, so we handle that for right pointer. Let's handle that for left pointer. Say s of left is alpha numerical. Left minus equals 1. Correct? Again, no, because I moved right here. So I have to make sure, again, I should need to add this condition here, because right might be changed here. So next time when I'm here, so I have to check it again. Maybe situation is in a way that doesn't satisfy the main condition of the while loop. Okay, but for the first one we didn't need that condition, because we're at the beginning of the while loop. We know nothing changed and we know the condition is right. Okay, doing that, now I can just run it. Let's see what we get. Okay, true. So this is correct. Now let's test it for another input. So for example, for s equals race a car, we get false. Okay, let's talk about time and space complexity. Time complexity is order of n, because we move over the sentence once from left and right. So we move from here and move from here. So we visit each character only once. So that is big O of n. And the space complexity remains 1, because we are not creating any array or list or anything like that. Okay, this is the solution of the problem 125, and thank you again for watching this video.